For the past couple lessons, we worked on multiplying fractions, and now we're going to extend that concept into multiplying mixed numbers. Before we begin, we're going to talk about some steps for multiplying mixed numbers. When we multiply mixed numbers, you can't just multiply the fractions and the whole numbers separately because the fraction part of the mixed number is connected to the whole number, so they have to stay together. Because of that, we're going to change all mixed numbers into improper fractions using the circle of math. Once we have our improper fractions, then we can go ahead with our steps that we learned in the last two lessons with multiplying fractions, where we multiplied the numerators together, we multiplied the denominators together, and then we changed the improper fractions to mixed numbers by dividing. Then we can simplify if necessary. Make sure you write these steps down on your notes pages to help you with your independent practice problems later. We're going to do the example together, 1 7/8 times 3 1/3. So what I was saying in the last slide is that we can't just do 1 times 3 and get 3, and then 7/8 times 1/3. We have to treat these as complete numbers. 1 7/8 is a mixed number. It is one number together. 3 1/3 is a mixed number. It is one number together. I'm going to do a little bit of mental math first to see what my answer should be close to. I know that 7/8 is close to a whole, so that means 1 7/8 is close to 2, and I'm just going to write that really small at the top. 3 1/3, 1/3 is not very big, so I'm going to say 3 1/3 is just close to 3. So when I get my answer from doing my fractions and mixed numbers, I should get an answer that's close to 6, because when I estimated or rounded my fractions to the nearest whole number, I got 2 times 3 is 6. So if we remember our first step that we wrote down, we do the circle of math to both of the mixed numbers to make them each improper fractions. So I do that with the first, multiply 8 times 1, and I get 8. And then I do 8 plus 7, and I get 15. And the denominator stays the same. And then I do it with the next number. 3 times 3 is 9, and then 9 plus 1 is 10. So now this problem is 10 over 3. I can go ahead and multiply first. 15 times 10 is 150. 8 times 3 is 24. Now I have 150 over 24, and I have to divide. 24 goes into 150 6 times. 24 times 6 is 144. And 150 minus 144 is 6. So I have 6 with a remainder of 6 24ths. Unfortunately, though, we're not done because we have to simplify the 6 24ths. So we have 6 and 6 24ths. I know that the GCF of 6 and 24 equals 6, so I can divide both the numerator and denominator by 6. And so I have 6 and 1/4 as my final answer. Now I can do this problem another way. If you remember from last week, I said that we can multiply fractions two different ways. We can multiply and then simplify, or you can simplify and then multiply. So I'm going to rewrite what I have right here down below, and we're going to try to do it the other way. And this should make it a little easier so that we don't end up with these big numbers at the end. I know that I have to look at my diagonals. So I'm looking at 15 and 3 together first. And I know that 15 and 3 share 3, so I can divide both the numerator. I can divide 15 by 3, and I can divide both the 3 by 3. So I'm done with those. Now I'm going to look at my 8 and 10. I know that they're both even numbers, so I can divide them by 2. I can do 8 divided by 2 and 10 divided by 2. So 15 divided by 3 is 5, and I'm going to scratch that out. We have 5. 3 divided by 3 is 1. 10 divided by 2 is 5. And 8 divided by 2 is 4. And I'm just going to make this look nice down below. So my first fraction would be 5 over 4. And my second fraction would be 5 over 1. Now I have smaller numbers that I can multiply. 5 times 5 is 25. 4 times 1 is 4. And this is still an improper fraction, so I do have to divide. So I would do 25 divided by 4. 4 goes into 25 6 times. 4 times 6 is 24. 25 minus 24 is 1, so my remainder is 1/4. So we got the same final answer as we got with our first way. This way we just simplified so we could have smaller numbers before we multiplied. In the top way, we multiplied first and then we simplified. So either way we get the right answer. So when you're working these problems out, you can do whichever way works better for you. If the top way that we did right here works better, use it. If you understand this way at the bottom where we simplified first and that works for you, use that strategy. But whatever you do, make sure the strategy you're using is giving you the correct answers, or it's not a useful strategy. The Hoover Dam contains 4.5 million cubic yards of concrete. The Grand Coulee Dam in Washington State contains 2 2/3 times as much concrete. How much concrete does it contain? So this is an application problem, which means it is applying a real-life situation. It is applying this concept to a real-life situation. So we're going to look, and I have times as much underlined because times as much is the clue that we're going to multiply those two mixed numbers. Times 2 2/3. The first step before anything else, because I cannot just multiply as is, I have to change both mixed numbers into improper fractions. So I'm going to do that first. 2 times 4 is 8. 8 plus 1 is 9. So my 9 here, the denominator stays the same. I will do the second mixed number. 2 times 3 is 6, and 6 plus 2 is 8. The 8 is the numerator, and the 3 stays the same. So I'm going to do it the way where we multiply first, and then we'll simplify at the end. So I'm going to go ahead and multiply my 9 times 8 and get 72. And then I have 2 times 3 and I get 6. And this is an improper fraction, so I'm going to need to divide. 72 divided by 6. 6 goes into 72 12 times. 6 times 12 is 72. And there's no remainder. Since there's no remainder here, that's the 0/6. I don't need that at all. It's a whole number. It's just 12. So 72/6 is just 12. So that means there are 12 million cubic yards of concrete in the Grand Coulee Dam. I'm going to do the same problem over here, but I'm going to simplify before I multiply. So I'm going to write my improper fraction that I already made, 9 halves, or 9 over 2, times 8 over 3, or 8/3. And I look at my diagonals. I'm going to look at 9 and 3 first. I know that 9 and 3 share 3 as a factor, so I'm going to divide both of them by 3. Now I'm going to look at my other set of diagonals, 8 and 2. I know that 2 and 8 share 2 as factors, so I'm going to divide both of those by 2. And I'm going to get my answers. 9 divided by 3 is 3, so that's my new numerator of my first factor. 2 divided by 2 is 1, so that's my new denominator. So my first fraction is done. Now I move on to the second one. 8 divided by 2 is 4. 3 divided by 3 is 1. Now I multiply just like I did before. 3 times 4 is 12, and 1 times 1 is 1, which is just 12, because anything divided by 1 is a whole number, so that's just 12. So again, you can do your problem either way. You should by now have a way that works for you the best. If multiplying and then simplifying works for you the best, use it. But if you understand the way where we simplify first and that makes more sense to you, use this strategy instead. Just make sure your strategy is getting you the right answer. Okay, now that we've done a few examples together, I want you to try some independent practice problems on your own. Do your best and use your notes that you've taken so far. Number 1 is 1 1/2 times 2 3/8. Number 2 is 1 1/2 times 2/3. Number 3 is 1 3/4 times 2 4/5. And then number 4 is going to be 2 1/4 times 1 1/2.